Okay, let's get started. Today, we're going to be talking about generative AI and the challenge of securing the data pipeline. I'm Dave Orban. I'm the Director of Product Marketing here at Superna, and we're going to be taking a look at some of the challenges of protecting your AI data pipeline and securing it from the increasingly sophisticated attacks, including data poisoning. First, a couple of housekeeping issues. We're recording the webinar, and both the recording and the slides will be made available after the event. And due to the number of folks on the call, your mics have all been muted, and any questions you might have should be directed via the Q&A or chat mechanism. We've got a lot to cover in the next 30 minutes or so. So if for some reason we don't get to the questions during the webinar, rest assured that we'll be more than happy to reach out to you on an individual basis following today's event. Here we go. So today we're going to be joined by Superna's Chief Technology and Strategy Officer. Whoops, we went one too far here. Get back here. Andrew MacKay, and also by our VP of Pre-Sales Engineering, Derek Manning. This will be a discussion around how to attain transparent security and integrity for your AI training models. Tremendous growth in the adoption of AI and ML has accelerated infrastructure investments and has introduced entirely new attack vectors. Compromised training data can make your AI investment worthless, and properly securing it is your best defense. So in this session, we're going to be taking a look at the risks. We'll show a proof of concept attack vector against machine learning infrastructure and propose a strategy that helps safeguard your AI and ML training data. We'll cover how the race to adopt these new technologies within the enterprise exposes the enterprise to new attack vectors. We'll examine some of the various risks and why these large data repositories have become particularly attractive targets. Like I said, there'll be a demonstration of an attack against a machine learning training model, and we'll discuss how Superna approaches these kinds of threats. And then finally, there will be a Q&A section at the end. So protecting AI training data involves several challenges. These training data sets often include personal information, which raises privacy concerns. Compliance and data protection regulations can be complex and difficult to manage. Safeguarding your data at rest and in transit using encryption and secure storage solutions is often one of the components of a security posture. Ensuring that the data remains accurate and unaltered during the collection, storage, and processing. And then maintaining audit logs in order to track who accesses or modifies the data, to basically to ensure the source of the data is legitimate and it's trustworthy. Addressing these challenges requires a multifaceted approach involving robust technical solutions, comprehensive policies, and ongoing monitoring and compliance efforts. While each stage has vulnerabilities, training data is a particularly vulnerable point in the pipeline. This is probably a good point to turn the discussion over to Andrew and Derek, and they can give us a little bit of an overview about the machine learning data pipeline.
Great. Derek, I think this one's you. Oh, you're on mute, Derek. Nope, still muted.
Yeah, there we go. This one's on me. So just basically in the spirit of the games that are going on, I think a lot of folks would recognize the gentleman to the upper left, Usain Bolt, as the fastest man in the world. An interesting story, though. He wasn't actually the fastest man to run over the course of 200 meters. Another gentleman, Johan Blake, was actually faster. You look at the times that are recorded in history. This is what history remembers, and that's Usain Bolt has run that time in 19.19 seconds. Johan Blake ran it in 19.26 seconds. So how could I say that 19.26 seconds is faster than 19.19? Track and field has a timing metric, which is your reaction time, or your time out of the blocks. The gun goes off and the clock starts, and then they record you to the tape. Your actual running time is never recorded, though. Your time in the blocks and sitting in the blocks is actually factored into your total time. In this particular case, Usain Bolt's reaction time was very quick. He was very fast out of the blocks, which is very important to our discussion here. His reaction time was 0.133 seconds, whereas Johan Blake's reaction time was 0.269 seconds. So he was like kind of sleeping in the blocks. He was very slow to get out of the gate, while he did end up running faster. But history doesn't remember Johan Blake at all. They remember Usain Bolt. And it's very important for organizations to understand that really second place is the difference between being remembered for all times or being a successful organization and enterprise, or being relegated to the past against your competitors. So getting out of the blocks is extremely important. AI models spend around 10% of their time in training mode and then 90% of their time in actual inference mode. Inference mode is when the model is actually being applied. So the application of the model where its truth is being proved out. The training time is when the model is actually created. So it's important to note that the time that you spend in training is factored into your race, getting out of the blocks and over to the finish line. You need to ensure that that training time for the model is spent very effectively and efficiently. You need to make sure that your data is sanitized, secure, it's actually got the right framework in place. Otherwise, you're going to end up stumbling out of the blocks and perhaps losing your race.
That's actually, Derek, that's one wearing a Team Canada shirt. So
Yeah, I'm not wearing any Olympic gear today, but we've got a pretty good track team in there as well. So I'm looking forward to watching some of these events. This is just an impact slide, like non-biological or artificial intelligence. Really, this will be the source of truth for all enterprise. We look at now the applications of AI and what we're seeing, where we're seeing it first kind of manifest itself. It was in chatbots and in AI assistants. Now it's starting to be used for suggestions and influence for consumers visiting retail sites, but it will continue to percolate its way into a business's intelligence, where every decision for an organization will be made using a higher level of intelligence, or an increasingly higher level of intelligence that is going to be the result of accurate training and actual inference application.
I'll jump in here. Surprising stat, right? We hear a lot about ransomware all day long, but of course, enterprises are running machine learning initiatives internally, and this was a Gartner survey that uncovered that they've had compromises of their AI environments. So that leads you to the obvious question: if there's a business you do business with that's using AI machine learning openly as part of their business model, and this statistic being true, probably underreported, then how can you trust the model or the output of their AI? And trust is something we're going to continue to talk a lot about during this session, where we're going to be talking about how do you build trust from yourself in your own data pipeline, but ultimately you need to project that trust and integrity of what your model's doing externally to your customers. Maybe it's an internal model, or if it's a customer-facing model, that trust factor has to go up. And there's been lots and lots of discussion. We've got some models we're going to talk about here about how you have to secure your data pipeline. But ultimately, it comes down to business reputation and credibility. And we're going to talk about some of the factors or some of the basic ingredients. It's a complex topic. There's lots of discussion around prompt injection and all kinds of things. But there's actually a more fundamental, basic underlying foundation that sits underneath pretty much all machine learning data pipelines. And although you're only spending 10% of the time in that training phase, the impact, if 90% of that model is going to exist, you have to get that 10% right. And getting it wrong means you spend most of the time with a bad, untrusted model, And there's all kinds of models. There's small, large language models. You could use GPUs. You could not be using GPUs. It doesn't really matter. But I think we also, through this discussion, want to demystify, what is machine learning and AI? Like, tangibly, what is it? Or what does it produce? What does a pipeline actually produce? Well, the inputs are files. I'm going to call files and objects similar thing, but let's just use files for this discussion. The input is files. The transformation of that data to get it ready or cleansed and ready for training produces more files. The training process, what does that produce? More files. What is an actual model? Like, what's a model? When you're doing inferencing, it's just files. So if it's all files, sounds like file storage and file security sounds to me like a foundational layer that you have to get right. So infrastructure that needs to be done right. This is a great slide. Sort of, to me, this is, again, a Gartner source slide. Models are great. We'll talk about NIST a little bit later on. But TRISM is the idea of applying a security model to develop and deploy and runtime. Those are two different considerations. We, Superna, we lean more towards that 10% that develop and deploy, because if you don't get that right, who cares? Your runtime is broken or untrusted or produces bad results. So you obviously spend a lot of time getting it right. It's also the largest attack surface. The model, at the end of the day, in terms of quantity of gigabytes, terabytes, isn't that big, but the training data that produced it is enormous. The attack surface is, percentage-wise, going to be that training and building data set, not the model itself. And where you run and where you build, that's like saying, dev, test, and production, they're not next to each other. They're in different environments, secured differently. This model doesn't show that clearly here, but the dev, test, and the production are two physically isolated environments, or should be. And the attack surface is enormous, and it's just a bunch of files. So if you look at all the different things you could secure, and there's lots of things, like the one I like is, third-party models that you're bringing in third-party code. It's not yours. You're trusting it when it comes in. All the libraries, massive amounts of open source. Who's vetting the open source, that there's nothing inside that. All legitimate concerns, right? These are all real things you have to do. But in order to compromise a model at a customer from a security standpoint, yeah, you could go modify the open source and slide that into every implementation around the world. You could do that. That was essentially the SolarWinds approach. For anyone that doesn't remember that was, well, let's just get before the signing process from Microsoft that signs the executable as being trusted. Let's just go before that step, and we'll pollute the source code at the source, and then it's going to get stamped with the Microsoft certificate, and then everybody's going to trust it. Well, that attack vector is identical that was used successfully there. That's the identical approach that you could take with machine learning. I could secure the runtime perfectly, prompt injection, output validation. I could do all of that perfectly. It's all pointless if I've already compromised the input. And so that's why that SolarWinds was quite a eye-opener to anyone who builds software, going, uh-oh, we need to harden the pipeline to build software. Well, software pipeline, data pipeline, no difference. And so all the things that you need to do to protect the source, in this case, it's not code, it's data, very analogous to the attack vector that was used quite successfully with the SolarWinds attack.
Hey Andrew, I want to add in here, I love this diagram as well, but there's also the fact that and what makes this so much more important now to protect the training data is the fact that, you know, when SolarWinds happened, the compiled binary went out. The next version of the compiled binary didn't really have a lot to do with the output of the previous version. And when it comes to generative AI, we talk about training, we talk about runtime. As the model runs in 90% of runtime, I think it's important that everyone remembers that the output of that model is being monitored and it's actually being used to feed back in to the next iteration of that model. Models have issues. They always do. They never come out right. There's bias, there are hallucinations, and then of course there's the threat of deception within the model itself. Now, if you're running the model for some period of time and you haven't detected that there's some deception placed in there, and you're counting on the output of that model to be good data, and then using that output of data to go back into the next version or the next iteration of that model, now you've got a problem where you could have poisoned data within your model embedded many times in deeply. If you don't really take care of the protecting the training data, then you also have to protect the output data because you're storing that somewhere, and you need to make sure that all access to that output data that you're collecting is being audited and protected against ransom attacks, et cetera, et cetera. So now we have this like double layer of protection where the storage is really at risk from deception attacks.
Yep, that is a good point, that the compounding of the compromise of the poisoning of the source data will get amplified by the fact that everybody knows you take the results and feed them back in to produce a better model. So let's imagine that someone understands that that's exactly what someone's going to do with their data pipeline. Then the missing ingredient is that the number of models people are using these days, they're not writing them from scratch. They're using libraries that are off the shelf. And so everyone has access to the model, and you can quite easily, which we'll talk about later, we have an actual demonstration of a poisoning attack. But because it's all open source and it's all really well shared and it's a process that's well understood, poisoning the data means you can predict what that will have as a knock-on effect, knowing that they're going to retrain with the data. So, you know, this isn't closed source. In fact, most of this is all open source because of the nature of the numbers of libraries that have been published online. And so attackers have access to everything. There's nothing they're missing. They could offline test their attack and then simply know exactly what it will do because they know what training algorithm they're using. They know that you're going to be retraining, and they know what your data looks like. So the ability to do this is, I'm going to say, approaching trivial in that there's no closed source here, right? Everyone depends on the open source and the models written by someone else in these implementations. So I think that makes the risk here even higher, because the attacker pretty much knows everything about the environment and the process that you're using, because it's a well understood process. And we've experienced this, and in fact, we set out with an objective internally to prove how easy it is to add data to a training data set with the goal of causing the prediction or inferencing to, in the case of our case, it was a security use case where we wanted it to hide the attacker's behavior. And that was possible by manipulating the source data in a way that the attacker's behavior would go unnoticed by the inferencing engine. So that's just an example where it's understood that the anomaly detection would feed back in, and knowing that the data was manipulated, you're compounding the ability to hide behaviors. And that's the scenario where there's a security product that's using machine learning, you know, to make predictions about bad behaviors. You can think of all the other use cases, you know, like stock trading, or there's a, you know, tricking an AI into predicting, you know, buy sell decisions, and there's all kinds of worse scenarios that you can imagine. But we wanted to use security as the use case, which we'll talk about in a few slides. But we're aligning to this model. And so where do we fit? So we fit in the whole development and deployment life cycle because we can secure the file and object underlying data stores. So as the data enters the pipeline, the chain of custody of data that enters, the who, what, when, where, you need traceability to be able to know what happened to the data when it entered the pipeline, how it got manipulated through the pipeline, and then ultimately what model was produced from that particular data set. And the trusted compute model in this context means we also need to trust the hosts and the users that are manipulating the training data. And so a solution needs to be able to look at the trusted hosts and users, the data sets, and draw a circle, a ring fence around that, and then be able to identify bad behavior of those trusted users and hosts, so a zero trust concept, and be able to play back who did what when at every stage of the data lifecycle. And if you don't do that, and you get asked a simple question like, well, how did the model produce that answer? You can't answer that unless you can trust and prove, and I'll use the word prove that the data you trained on was not modified by anyone other than the trusted hosts and users. And there's no other risk of data poisoning. If you can't prove that the data wasn't poisoned, then how can you possibly trust the answer or the inferencing of any given model? And so today we don't have regulations. We have many regulations for HIPAA, PCI, FedRAMP, like a long list of regulations. As it applies to file-based storage, all of those standards have one thing in common. If the device is storing data that's in scope for this PCI, HIPAA, whatever, then you must have user data access auditing. All of them, without exception. That is a fundamental basic infrastructure requirement. Although there's no one looking at regulations around machine model, I suspect that that's coming, that there'll be standards in place, but ultimately we should take a page from all the previous standards and regulated industries that have shown the way, which is you need to know who touched the data when and have traceability to every access today and in the past. And that's how you build a secure, trusted environment. So I don't think this is a special use case. I think it's an area where there are no regulations and those same foundational requirements exist here, just like they do in a hospital scenario. Our favorite slide, Derek, why don't you cover our favorite NIST model?
Sure. Yeah. I mean, it's important with whatever solution that you're using to start with a solution that's built on a framework, a proven framework, that is. We architected our solution with the NIST framework in mind, and we're lined up completely with the quadrants or the 5 sections of the NIST framework, which are, identify, detect, protect, respond to, and recover from cyber events when it comes to cyber storage. So identifying is knowing who did what and when. Detecting is using some level of automation, because most of the time these automated attacks are coming in against your data sources, and the only real good response for an automated attack is automated detection and automated response. So have some sort of machine learning based solution protecting your data and detecting any of these attacks that are coming in as a vector against both your training source and your result output data. Protecting the data as well. So being able to provide immutability against that data, and then responding to those attacks as well and recovering from. So this is a slide that we've been speaking of for many years now with our ransomware protection solution for unstructured data in general. But it definitely applies to machine learning and AI training data as well as results data that we have.
And I think it's the next slide, David. The NIST framework they've gone and identified, a risk management framework around AI. There's a bunch of work from a bunch of organizations. This is the NIST evolution essentially, and we're just going to call out, secure and resilient. And it's pointed out here that data poisoning, exfiltration of the models, training data, intellectual property of the models themselves is a paramount requirement. And so again, I go back to, well, what is a model? What is training data? They're just files on unstructured data platforms, right? So that means you need a unstructured data security solution in order to track user access, chain of custody, and anomaly detection. Resilient, that's more of a DR component, but in order for your training model to survive anything, it's also going to need the ability to be able to fail over or have a resilient platform. Most customers that we're talking to, they're not doing DR for their AI models. The data sets are quite large. The cost to replicate is high. And in a lot of cases, they can regenerate the data or they can collect it again. So we're not seeing DR as a huge requirement around these types of environments. But security is the one where everyone hears lots of things about it, but nothing specific stating, well, what should I do? And I like to look at it from the perspective of, you have a limited budget. Who doesn't have a limited budget? What's the one thing I could do that would materially advance my security posture around my data pipeline? Well, since data pipelines are just files on unstructured storage platforms, you should have a anomaly detection and historical auditing of user data access. That's the one thing you should do. And yes, there's a long list of other things you could do, but that's a foundational requirement. I like to say it that way because foundational is something everyone should do. Is everybody going to need prompt injection detection and all the runtime things? I think it depends on how you're using models and AI in your business. But no matter what you're doing, the pipeline is the number one attack surface, and it has foundational security requirements. So we simplified. This is of course not the entire AI security stack, but from a storage perspective, which is a big component of any machine learning data pipeline, we wanted to build in sort of 3 core tenets that we think should exist. Forensic data access and traceability. If you don't know who did what when to your data, I don't know how you trust anything being built by that. I'll come back to the code example. Inside Superna, we've got a 2-phase commit process. So it's a 2-factor software commit. You can't commit code to the code base unless there's a 2-factor trust model to every single commit and traceability of who did what when to the source code. Well, you need the same analogy for your pipeline data. So you need to know who did what when, from where, which host. Then we look at anomaly detection at the storage layer. If you can't discern normal from abnormal user behavior, then you may be unaware of your data being exfiltrated, being accessed inappropriately or updated. And so patterning malicious activity is super critical. And it's the one layer that has the most visibility to the attacker's ultimate goal. Like, no attacker wants to hijack computers in your corporation. They want to get to the computer to get to the data. The data in most modern enterprises sits on large unstructured data platforms, file systems, and object platforms. And so you need anomaly detection being done there. Why? Pretty simple. The protocols involved these days, SMB, less so NFS, but S3, it's all encrypted. So what am I going to be able to see from a intrusion detection platform? I can't see the payload. I can't tell you if it's a read or a write. It's all encrypted payload. There's only 2 places to look at the anomaly: the endpoint or the receiving point, the storage. We are the centralized view of all endpoints, Windows, Linux, Mac, doesn't matter. We can see it all. and that metadata lets us do anomaly detection. So super important. It's easy to say you need to do anomaly detection, but where in the stack should you do it? We believe the storage layer, because the network layer doesn't even know what's going on. It's all encrypted. The endpoints, well, there's too many of them. It's easier to do that at the aggregation point, and that's at the storage layer. So we've put this into a framework. Again, focus on the storage layer under the cyber storage category. That's the Gartner category for the securing data at the storage layer. And so we've got both our security edition that obviously has historical forensic capabilities. We've got anomaly detection at the storage layer for file and object. That's important because pick your protocol, pick your storage platform. It doesn't matter to us. We've got a unified solution. And then we've got the zero trust model being applied over top and ensuring that you've got a way to make immutable copies of your whole pipeline as you're building, testing, training. So this is the model that we're putting forward at the storage layer. That's that one little area of security we think is most important.
Yeah, one thing I want to add on here is, like, you know, as our solution is built on a framework, I think as a consumer or as somebody who's applying AI or performing the training themselves, they should be looking at the correct framework that they should be training within. So just highlighting all those key areas, right? Protecting the data. So being able to report on access, like the governance of the data, who has done what when, if you're training the data yourself specifically. Applying a lock before training so that the data is immutable and secured, and then a good clean source of data is going through the training model. It's not conceivable that every consumer or every organization is going to be training their own AI models. We're already seeing like the trend towards contract manufacturing, just like the chip vendors do. Not every organization can afford a farm of $30,000 GPUs. But there are organizations that is going to be their business model. Come to us, we will train your model for you and deliver it to you. If you are selecting a contract manufacturing or a contract training solution, make sure that they're also applying this particular framework of solutions. The cyber storage AI ML framework is good for you, but it's also good for whoever you select as a contract manufacturer for your models to be applying as well. Make sure that they're running cyber storage.
So this is our
Yeah.
go ahead and play. So we built a model that looked at read and writes, and we trained off of audit data that was fed into the model. And right now we're doing inferencing. So we take the model, we're reading in audit data, and we're looking for anyone doing out of the ordinary reads and writes, looking for data exfiltration. So we find a host that is doing a behavior of massive reads of your data, and they don't normally do that. It's not part of their normal workload. So this is good. This is a security detection of a problem. So what we then did is we just manipulated the training data and rebuilt the model. And if I'm the attacker, I would inject read data into the training data. And what ends up happening is the attacker has now masked what they're doing. So they're still doing what they were doing before, being detected as an anomaly. Now they go undetected. So again, the trust of that data pipeline is clear. If I'm an attacker and I have access to the training data, I can just small modification and I can now go undetected. And this is just a proof point. When everyone talks about the theory of data poisoning, well, we did it. That's exactly what it would look like. And the manipulation isn't that difficult to do. Actually, I should point out, the training data was a CSV file. So can anybody edit a CSV file? Pretty basic stuff, right? I'm not hacking into Oracle. I'm not doing any of that. I'm just manipulating a CSV file. So why don't you take this, Derek, take everyone through our solution here.
Right. Yeah. So Superna offers a number of solutions that can help you secure and protect your data all the way through an AI and ML process. So number one, on the left side, you've got your production data stack here. And here's where you want to have the data security edition running and protecting your data against any sort of pollution or contamination when it's being created and inbound and ingested. Now, we show our orchestration edition here as well. For those not familiar with our orchestration edition, this is our file to object solution that can read files off of a file system, encapsulate the file system metadata and store that so that every file is a self-contained version of itself, complete with the ownership and last access date and other metadata that we can inject in there. And then it can be transformed and transported into an AI processing farm, as an example. And this is where you would get your models being generated and created. So we'll make version-aware copies of all your ML data, training sets, etc., and then orchestrate it back down to a secure repository. And again, as we're picking up the data with the orchestration edition, we check in to make sure that there aren't any live or active events going on in your production environment. So no data is sent if there is an alert raised. But if there are no alerts, we pick up the data, we can orchestrate it into an object space, and then once the data has been finalized and pre-processed and ready for application as an inference model, or the output has been collected, we can then bring it into your object repository, store it there, and apply the same levels of the data security edition, the chain of custody capabilities, all on the object output as well. Do you want to have a go at the integrations, Andrew?
Sure. So we've engaged a lot of customers around the world, and the storage teams are investing in securing their data because that is the target of the attack. Yet we have a different group of people at an enterprise that are responsible for overseeing threats to the corporation of any kind. So that mismatch needs a solution. And so this is the solution. We've taken an integration first strategy, which basically means the user experience to protect the corporation's data should exist in the tools that the corporation uses to secure the infrastructure for the corporation. So this is an ever-growing list of security platforms. Primarily, these are SIM and SOAR platforms, but getting our rich root cause alerts of like this user has done this bad behavior to this data on this date, and we snapshotted that data, and here's a summary of all that information. So here's the indication of compromise, and getting that into the tool of choice in a way that the user field is mapped to the user field. The SMB share is mapped to the asset field. And so getting a native integration means the alert looks and feels just like a native alert in any of these tools. So that's step one. And we've got an ever-growing list here. The second step is, I'll use a use case, is bidirectional integration. So playbooks and workflows. Typically the name that a SOAR would give to some action that a security professional can take in those platforms to act on an incident. So my favorite one is a phishing scenario. A user account has been phished, and that bubbles up into a security tool. That security professional has a bunch of actions. If they believe an account's credentials are compromised, they probably want to disable the user's AD account. But remember, the attackers doesn't want the AD domain controller. What they do want is the data that user had access to. So imagine I'm that security professional. I enter the username into a playbook, and I hit go, and it goes out over an API to Superna, and we look up that user's access across the corporation, and we real-time disable their access to corporate data, thereby fencing that user off from the data, denying the attacker what they ultimately want. That's great. So we've stopped the attacker's ability to use those compromised credentials. What else might I want to do as a security professional? Well, it would be nice if I could create an immutable point in time in case there's other compromised user accounts that I have to deal with. I would love to get a checkpoint across my corporation's unstructured data, but I don't know who to contact in the storage team, and I need to do it right now. Well, that's another playbook you can run. Sends in the request to Superna. We've got the concept of critical data, and we can snapshot using the native capabilities of the storage devices, create immutable real-time snapshots across the infrastructure, protecting that data and creating a restore point if it ever becomes necessary. It's a pretty easy, understandable use case. And this is something that we offer to all of the SIEM and SOAR platforms that offer that playbook workflow, because we believe we need to get the decision-making and the response in the hands of the people that are ultimately paid to protect the corporation's data. We can automate actions, and we do that at the storage layer. But there's other scenarios where we need to empower other parts of the corporation to take action to protect the corporate data. And that's just one example of a bidirectional integration. But this is cornerstone to our strategy of protecting corporations' data through these types of integrations.
Yeah, absolutely. I mean, the security teams are the ones who are monitoring your infrastructure and protecting your infrastructure on a day-to-day basis, 24/7 out of their security knock center. They have no idea, or the storage team will have no idea when a training model is about to be launched and started. So why not have it just go right into that 24-hour, 7-day-a-week monitored infrastructure where the security team is always on top of things. They get notified instantly. They can orchestrate and coordinate response throughout the multiple teams. And that's where all of that coordination and orchestration of security response really is already centered in organizations. And that's right within, these security SIEM and SOAR platforms. So getting our alerts and getting our information into there in a very rich format with lots of detail was a really large step for us over the past year or so, getting these integrations done. And I know that Andrew's team in the CTO office has done a tremendous amount of work with a lot of the integrations, and we're continuously adding more and more integrations as time goes on. So this is a really important part of the security model, which is like the actual notification and getting those alerts to the right place.
So we're at the point where it's time to address some of the questions that have come in, and the first one is tied directly to the integrations. I would have to imagine that let me see what it says here. These integrations are designed to reduce friction and increase adoption. Is that something that's a fairly accurate statement?
Yeah, I would say so for sure. I mean, like having another tool for storage team or security team members to look at is not always desirable. They've got a lot of tools and a lot of applications to monitor and look at. So carrying that into a centralized, streamlined application or view within an organization is absolutely essential to getting a quicker response and a more effective and efficient one.
So in other words, use the tools that you already have at your disposal. You don't need to go out and learn another UI, right?
Yeah, you've built up procedures, operational procedures throughout your organization for all of the response. So this is just another input that your already existing response framework will be able to react and respond to.
All right. A lot of talk about the threats in the data pipeline. What do you think is the key attack surface?
Yeah, I mean, I can take a stab at this one as well. I mean, we have the source training data, which we spoke about. And Andrew, I'd like to actually kind of ask you as well. I mean, we really do focus on a lot on the training data and the mass amounts of training data, but what about the results data? What about the output data? How much data is that generating, do you think, as a ratio to training data?
Well, there's raw data, then there's the pre-processed data, because no one's data is produced in a format you can train on directly, almost never. So you take the raw data and then you create another version of that. And so those are two attack surfaces that you can easily get to. Then when you run the models, it produces model files. And so I can swap out an old model file for a new one and basically roll the model back, right? Like, let's say your vulnerability, you attacked model version 6, and we're now at model 9. Well, I'll just replace the PKL files with the old ones, and boom, I've brought the model back in time, And if no one can verify that that model file was changed or who did it, then it's easy just to swap out the model files because you're producing them all the time. There's tons of them. So traceability and protection of the actual model files, because the model files are in fact used by inferencing, right? That's what's actually being used to make the inferencing decisions. So the attack surfaces are many, are almost unlimited when it comes to the data pipeline. And they're trivial. As I mentioned, like CSV files, like you don't even need tools. Every operating system comes with the hacker tool, right? Nano, Vim, Notepad. I mean, that's it. That's all you really need in many cases to manipulate training data. And I can't forget Awk and Sed, my other favorite Linux tools. Yeah.
Is there a difference between, does the attack surface change between the development of the AI versus the production that is produced by the AI? Is there a difference in the attack surface?
Yeah, I mean, I would suggest that those, like prod and dev, like those are best practice says those are physically isolated environments. And so that someone's got to transport the golden model file over to production, and those are isolated environments. So there's definitely very different considerations. In fact, let's just start with immutability. I mean, if I'm going to be inferencing 90% of the time, well, then maybe I should make the file system that my model files read only. It doesn't need to be editable. So can you have a non-editable dev test training environment? No, I'm constantly creating new, so that wouldn't work. So that's why we like to try to draw that physical split between prod and dev. That A, they're separate, but B, the security requirements they change quite radically from one to the other. You're not worried about prompt injection in the development environment. Like there's no prompt. It's not in production. So yeah, I think those are wildly different, and like, garbage in, garbage out. So we're focusing on the obvious lowest hanging fruit attack surface, which is the dev environment. If 90% of the time you're just inferencing in and out all day long, yeah, you'd secure that very differently.
What are some of the anomaly types that you look at to determine whether or not you've got a bad actor messing around in your storage?
Well, there's when we built models, we tune it for problems. So data exfiltration is a good one. It's a tricky one, right? Because what is data exfiltration from a storage systems perspective? It's a user reading data. Like that happens all day long by everybody. So now the problem statement is who's reading data that doesn't normally read data? Who's reading data in an area of the file system that they rarely ever touch? What's the rate at which they're reading data? Where are they reading data from? They usually use host X. Now they're on host Y. That doesn't happen. So the problem statement is a complicated one, but it's actually a purpose-built problem for machine learning. It's perfectly well suited to looking at what's normal. And so we would build a model that's tuned for reads with a bunch of weighted factors. And that model would be a small language model looking at data read anomaly. If there's a different problem, we would do a different small language model. And I like to distinguish small and large. Everyone hears about LLMs, right? ChatGPT, enormous environments. But a lot of the machine learning and AI inferencing is going to be small language model stuff that are business specific, purpose built to solve a particular problem. So the good news is it's not like there's one model that you can pollute. There's a whole bunch of little ones. So that's sort of security through obscurity. Well, there's lots of models. They can't get them all. But at the end of the day, most of the models are tuned for a particular problem. And exfiltration would be one. Ransomware behavior is another. Mass delete, data corruption. So there's
Yeah, we just had one too, Andrew, that it came across the newswire with a company that hired like a North Korean hacker, right? So they were able to determine that it was a security company that hired him, and he was working within the company, and they were able to determine like the access patterns to the data just didn't fit for what should be happening on that
for the job
data.
for the
So
job.
that's like number
Yeah.
one. I would extend David beyond the behavior detection to, okay, we detected bad behavior. Now we need to be able to audit and figure out what were all the other files that this guy touched as well, or this person touched as well.
Yeah, and if you can't answer that question,
oh,
it puts your whole enterprise data integrity at risk. Can you imagine if they can't answer that? Well, we don't actually know what that person touched. Like, holy cow, how do you trust any of your data?
that's
Right.
right.
So
So,
it's such a foundational layer of security that is so often overlooked. And I would hate to be the one answering the question to the CEO. What do you mean we don't know who touched that data? We know the username of the user that was compromised. You can't tell me what they did. We hear that all the time. I've even heard of a police force where evidence was deleted, and they're like, well, who deleted it? We don't know. So yeah, it's such a foundational
if
layer.
you don't know what was deleted or who deleted it, then you have no chance of figuring out what else was touched or what else was deleted. So the auditing and behavior detection, they go hand in hand, are absolutely essential to any cyber storage solution, protecting not only your AI and ML training data, but your corporate data, just as a general rule of thumb.
Yeah.
I think we got time for about one more question here. And this one says, it sounds as if you have incorporated machine learning and AI to better understand attack flows and identify patterns and indicators of compromise. Is that the case?
Can you repeat that again? So I missed the.
It sounds as if you're using machine learning and AI to better understand attack flows and identify patterns and indicators of compromise. Is that the case?
Yes. There's also the idea that you're holding a machine learning hammer, everything looks like a nail. So I don't want to suggest that machine learning is the only way to do something, because that is completely wrong. It's a great tool, but you got to use the tool for the right problem. One of its downsides is it needs to train, and training isn't in milliseconds or microseconds, right? And it needs a certain volume of data before its predictions are trustworthy. So that relegates it to certain problem statements. So you need a combination of detection capabilities that are built for the problem and the vulnerability that you're going after. There's no one size fits all. I like to point that out because as great as the marketing machine has been around AI, and it's the best thing we've ever seen, and it's going to take over the world, and LLMs are it. There's nothing else out there. It's the right tool for the right job, and that answer doesn't change today, tomorrow, the next day. And so, we take a comprehensive approach, like, well, what's the problem? And then we select the best tool.
Well, this has been a terrific discussion. We've had some great questions, some great engagement. There are a couple of questions that we did not get to today, but rest assured that we will reach out and answer them on an individual basis. On behalf of Andrew, Derek, and myself, thanks so much for spending time with us today. We hope you found the presentations to be informative. Like I said, rest assured, if we didn't get to your questions, we'll happily reach out to you after the webinar. Our LinkedIn information appears on this slide, and if you'd like to continue the conversation, feel free to reach out. You can visit our resource page on our website to access blogs and webinars on a variety of related topics. And with that, thanks again for your participation, and have a great rest of your day, and hope to see you again soon.
Thanks a lot, everyone.
Thanks.